Kubernetes will run almost anything you hand it. That is the point and also the problem. The orchestrator ships permissive by default because defaults are tuned so that things work, not so that things are safe. So every cluster accumulates settings nobody revisits. Posture management is the continuous job of reading what the cluster has actually been told to do and holding that declaration up against something stricter. That stricter thing is a hardening baseline, a written set of expectations about how workloads, identities, and network rules should be configured, not a list of vulnerable packages, a list of safe settings. The output is a stream of findings. Each finding names one concrete setting in one concrete object and explains what it would let an attacker do if they ever got a foothold nearby. Some findings are about identity, who or what is allowed to ask the cluster for something. Role bindings drift wide over time and almost nobody goes back to narrow them again. Others are about the network. By default, in a fresh cluster, every pod can talk to every other pod. A network policy is how you draw the walls that were never there. But here is the twist that makes Kubernetes different. The cluster is declarative. It is rendered from manifests in version control, so the live cluster is an output, never the place you fix things. Which means the real win is not finding problems later. It is refusing them at the door with an admission policy engine that will not let a violating workload into the cluster at all. Take 1, the posture tool connects to the cluster and reads its declared state, every workload definition, every role binding, every policy object. It does not need to run anything or open any traffic. That declared state gets compared object by object against the hardening baseline. The question is never, is this software old? The question is this setting wider than it needs to be? Hold that distinction because it matters. Image scanning looks at the packages inside a container and asks whether the code is known to be broken. Posture management looks only at how you configured things. So the findings start arriving and they sort themselves into a handful of recurring classes. Almost every cluster in the world produces some version of the same short list. Let us walk it. Class 1, a workload running as root or carrying the privileged flag. Privileged effectively erases the boundary between container and host. The container stops being a box and becomes just another process on the node. Class 2, mounts, a host path bringing the node's file system inside. The host network removing the pod's own network namespace, or the container runtime socket, which is effectively a key to every container on that node. Class 3 is quieter, missing resource limits. No memory ceiling, no CPU ceiling. One noisy workload can then starve an entire node and take every unrelated pod scheduled beside it down with it. Class 4 is identity, a service account that only ever needed to read one config map, granted cluster admin because that was the fastest way to make the deploy succeed one afternoon 2 years ago. Same family, the default service account token, mounted into every pod whether that pod ever calls the API or not. A credential sitting in a file system that has no reason to hold one. Class 5, no network policy at all, which means any pod can reach any other pod across every namespace. It is the old flat network problem, wearing new clothes inside your cluster. In Class 6, secrets held as plain environment variables. They show up in process listings, in crash dumps, in logs, and in every debugging session anyone ever runs against that workload. Now the fix, here is where teams get it wrong. They patch the live cluster and the next deploy quietly overwrites the patch. The fix belongs in the manifest in version control. And once the baseline lives in code, you can enforce it at admission. A policy engine inspects every incoming workload and simply refuses the ones that violate the rules. No violation, no cluster. Push it further left still. Run the same baseline check in continuous integration against the manifest itself. Then the review fails before merge, and the bad configuration never even reaches the cluster's front door. Drift detection covers the rest. Someone makes an emergency change at 3 in the morning directly on the cluster and never reverts it. Drift detection compares live state to Git and shouts about the difference. Now the honest part. A baseline applied bluntly breaks legitimate workloads. Some things genuinely need a host mount, so exceptions must exist, but they must be explicit, owned by a named team, and time-limited. The failure mode to avoid is the silent exception, a rule someone disabled to unblock a deploy with no owner and no expiry. That is how a baseline slowly becomes decorative. So that is posture management. Read the cluster's declared configuration, compare it to a hardening baseline, surface the risky settings, and then move the whole check left into Git, into review, and into admission control. That's the whole trick. Next time someone says the cluster is secure, ask a better question. Secure according to which baseline, checked how often, and enforced where. Follow how it all runs for more. See you next time.